and you start dumping salt in it. Well, guess what? The temperature goes up, 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 103, 104, 105 degrees centigrade. And it turns out that you can calculate exactly how much that temperature is going to go up. This is called a boiling point elevation. Delta T sub B is the mathematical symbol for that. So what are some before we throw the math out, what are some applications of this? Well, first, all right, I'm from Tennessee. So let's say, well, it'll always do this in Tennessee, it starts raining during the day when the sun's out. And it's like 34 degrees outside. And as soon as the sun goes down, it gets down to 30 degrees outside. So what is that going to do to the rain on the road? Make it freeze. And then very likely it'll snow on top of it, right? That's Tennessee's claim to fame problem. Is it rains first, see, because it ain't cold enough during the day to just go ahead and snow like a normal place, right? It'll rain first, put the ice on the road, then it'll snow that night. Then you got a world of shit to deal with the next day, right? I'm serious. I mean, you're slipping and sliding, can't drive and everything. Well, what they do to deal with this is they'll take the salt trucks out and put salt on the road. So when you put salt on the road, what's that going to do for you? Well, if it's 0 degrees centigrade outside and you add a layer of salt, what's the new melting point of the salt going to be? Like negative, it's going to be what now? Well, yeah, I mean, the freezing point of the salt's going to be like negative 5 degrees centigrade, right? So as long as the outside ambient temperature does not go below negative 5 degrees centigrade with a layer of salt, then guess what? The water is melted, even though it should not have been melted, right? But the reason we're melting it is because we're putting salt on the road, bringing this number down. Now in some places, like up in northern Wisconsin, northern Minnesota, will ice do you any good at certain times of the year? I mean, once it gets so cold, what's going to happen? Nothing. That's why a lot of time, I mean, you know, you're up in St. Paul, Minnesota, and it's like a really bad storm, and you see these ice trucks and stuff are running. Sometimes they'll just turn off their lights and head back home. Because it don't matter how much they put down, they will not get the temperature, they won't lower this enough. It's just a useless game, right? When you start getting into negative 30, and I mean, stop that. That's cold, right? Ain't nothing going to work. You just stay at home, all right? Now, what about the freezing, the boiling point elevation? How's that going to work for you? Well, look at the antifreeze in your car. Even though it's called antifreeze, and in northern states, the antifreeze does what? Like if your radio's rated at 30 below. What that means is it would have to get colder than 30 degrees below zero before your antifreeze freezes. Well, what happens as a couple? It also raises it. So on a Miami freeway, when the temperature is greater than 100 degrees centigrade inside your car, it does what? It acts as a coolant. So that's why antifreeze, if you read on the bottle, it's an antifreeze / coolant. It does both. If you happen to be in a cold weather environment, it will prevent your thing from freezing. If you happen to be in a hot weather environment, it will prevent your car from overheating. Does that make sense? They all happen in couples. Now, the formula for this is delta T sub F equals K sub F times little m, and delta T sub B equals K sub B times little m. Well, first off, we know what freezing point depression is. That is how much it goes down from the solvent. Freezing point, boiling point elevation is how much it goes up from the solvent. K sub B and K sub F are constants. You'll look those up in tables whenever I start asking for them here. And little m is something that's called molality. All right? And what molality is another way, number 5. Molality is little m, and that stands for why is my mind just went blank? Am I thinking about Christmas vacation? What am I doing? Okay, this is going to be the moles of the solute divided by the kilograms of the solvent. That's what molality is. Moles of solute divided by the kilograms of the solvent. We got two new things here, moles and kilograms. That's what molality is. Now that is not to be confused with capital M, which is also in this chapter we ain't talking about right now, and that's called moles of solute divided by liters of solution. Okay, that's different. This is little m. So, tell me the new freezing points and boiling points of a solution that contains 128 grams of sugar with 1,000 grams of water. So here's what I'm looking for. I want to know my new freezing point and my new boiling point of a solution that contains 128 grams of sugar and 1,000 grams of water. All right, so if you're in your kitchen, here's what we've established. All right, we've went to the freezer, and we've established that water, the pure water, freezes at 0 degrees centigrade. We went to the kitchen and we've established that pure water boils at 100 degrees centigrade. That's established. All right. Isn't that right, Bonnie? Yes, wonderful. Okay, now we're going to take and put 128 grams of sugar into 1,000 grams of water and see what happens. Okay. So, the boiling point elevation is going to be the capital B times little m. Well, let's calculate little m first. Well, little m is going to be the moles of solute. So where's the solute here? Water or sugar? Solute. Sugar. It's the one in the least amount. Okay. So that's going to be 128 grams of C6H12O6. 180 grams of C6H12O6 per 1 mole of C6H12O6 divided by the kilogram of the solvent. So how many kilograms of solvent do we have? Right, 1 kilogram, right? There's 1,000 grams on the board, but she's converted in her head to 1 kilogram. All right, so what is my little m? 128 divided by 180. What you getting? 0.7? 0.711? Is that what you guys are getting? Okay, so that's my little m. Now what is my KB out of the table? There's a table right close to you there. Huh? It's a constant. And the B stands for boiling constant. And it is on page what's that number? 355. 355, it's in a table. It's called the boiling point elevation constant. What is it, 0.512? What's that? No, water. 0.512 times 0.711. So what will this be here? This will be my new boiling point, just like I want. All right, it's the boiling point elevation. So 0.512 times 0.711 is going to be 0.36. So what's going to be my new boiling point here? 100.36 degrees centigrade. Do you see that? So, Bonnie's in the kitchen. She's measured out 1 kilogram